Good morning, students. Welcome you all on YourPedia panel. So, dear students, today we are going to discuss the top 20 problem of theory of computation for your upcoming ISRO exam. As you know, YourPedia already started the series in which we are covering the top 20 questions of each and every subjects. And YourPedia also running a dedicated batch for ISRO. So, if you are a bit interested, then you can join and contact to our executives. So today we are going to discuss the top 20 problems of the theory of computation. And here is the first problem. It says that we need to find out the minimum number of states in DFA. Question says that what are the minimum number of states for the language that is set of all strings which contain substring, okay, A, B, A, B. The question statement is, what are the minimum number of states required in DFA to accept the language in which all the string that have the substring AB, AB. So let's draw the DFA for this one. AB, AB. We required AB, AB as a substring in each and every string. That is the part of my language. AB, AB. And substring means consecutive sequence of symbols. Fine. After accepting the required things, it may be anything. That's why it's a loop. Now, if I say, because my string start with A, fine here. Now it may also start with B with any number of B. Then B, A, fine. Now it may be the case that at state 2, any number of A may present. Next, now at 3, if B comes, what I have to do? If B came, again I have to start because it is not acceptable. A, B, B. Fine. So if the new B came, I have to again start from my starting of the string. Next, at state number 4, if A came, again we have to start the string. That is A, B, A, B. Fine. Yeah, that's the DFA, and which required 5 states. So B is the right answer. Always keep in mind, my dear students, whenever a question related to the substring language, so we know that what is the regular expression for the substring. At the end, it may be anything. At the starting, it may be anything. But we require the substring part at this level. Fine. Always keep in mind, whatever the length of the substring, the number of states required in DFA is length of substring plus 1. There is no dead state in substring machine. So what is the length of substring in our case? 4. That's why 4 plus 1 is 5. So B is the right answer. So in the simple way, no need to draw the DFA. Always keep in mind, if the language is related to the substring case, then if question asks for the minimum number of states in DFA, then directly find length of the substring plus 1. Let's move on the second question. Which of the following statements correct? This is the question related to the closure properties of regular CFL, CSL, RE, and REC language. And that's the very important topic. At least you may find one or two questions from this topic. We already circulated or we already discussed the chart in our regular classes, and students know that what is the closure property of CFL and what is the closure property of RE. Now the first statement is CFL, that is context free language, is closed under intersection and complement. So if I talk about CFL, CFL is not closed under intersection, not closed under complement. Fine. So, but the statement says that they are closed. That's why the first statement is false. RE is closed under union and intersection. That is recursive enumerable language. So a recursive enumerable language is closed under union. It is closed under intersection, but it is not closed under complement. But question says that union and intersection. That's why it is true. That's why second only. Again, B is the right answer. So keep in mind, you have to remember all the closure property chart and the decidability chart. Again, how many states are present in minimal DFA that accept all the string of the regular expression? So regular expression is given to us and we need to find out the minimum number of states. So the regular expression is A star, B, then A plus B ka whole star. So A star, that means this is my starting states, A star. Then B, it's fine. And then anything, that is A, comma B. So it required two states. Very simple answer. Sometimes students mark it as a 3, but correct answer is 2 because it says about the minimal states. Okay. Now again, this type of question also you find in your any of the exams which are related to the CSE. The one is closure property chart and one is identify the languages. Now see, consider the following language L1 equal to a to the power I, b to the power j, c to the power k, where there is a one comparison between I and j, and there is a comparison between j and k. That's why at a time we have more than one comparison. It's not CFL, it is CSL, but it is CSL. A to the power m, b to the power n, c to the power n, d to the power n. Beware, but the condition is a and bm. That means it's just a language like this. All the element has to be same. Again, it is CSL. It's again reverse matching, but in this w and w straightforward matching. Again, it's a CSL. So language which are not context free, very good, which are not context free, all the language are not context free. So what is the right answer? 1 and 2, 1, 2 and 3, 1 and 3, none of these. Language which are not context free. So all the three languages are not context free. That means right answer is one. We have one E option. All of these are not context free, but they are context sensitive language. Is the right answer. Now, the minimum number of states in DFA for language set of all string over A and B in which first two symbol are same. Very important problem. So my dear students, whenever the questions related to first two symbol, that is last two symbol, then we are talking about here the case of same. In the similar way, if we have the case of different or start and end with same symbol, all requires 5 states. The answer is 5. So the minimum number of states in DFA for language, first two symbol are same. See, if we require first two symbol are same, it is like this. A, first after getting the first two symbols same, it may be anything. In a similar way, B and B. What about if first two symbol are not same? Then make it as a dead state. B, A. That is a simple DFA, which requires 5 states. Next, consider the following DFA, and then the language accepted by the DFA is what? Very important problem. All strings start with either A or B. This option is absolutely true, but it is not completely true. We know that from S we have a loop of A, and from S there is an outgoing arrow B. So every string has to be start with A or B. But every string which starts from either A or B are never going to be accepted or recognized. That means suppose that we have a string simple A, we have a string A. It is going to it is not going to be accepted. That's why my first option is false. All string end with either A or B. Again, there is a loop of A or B. Yes, every string has to be end with A or B, but it doesn't mean that every string which are end with A or B is going to be accepted. We have a string W equal to A, which is end with A, but it is not going to be accepted. All string which contain at least two B. Again, this is also false. Why? We have a string DAB which contain at least two B, which is not going to be accepted. It end at state A, which is my non-final state. Again, false. What about the D? All string which contain conjugative to B. Yes, that is absolutely true. Why? If you want to reach to the final state, anyhow, you have to read to B in conjugative manner. That's why option D is true. Which of the following regular expression denote set of all string not containing 100 as substring? See, in this type of questions, you have to just check the regular expression and find out which is the correct. Now, we require all the strings which doesn't contain 100 as a substring. Can I generate a string which contains consecutive 100? Yes, by 0 star just taking as a epsilon, then from 1 plus 0 ka whole star, that is a universal thing. So you can generate 100 from here. So this is not true. Next, 0 star 1010 star. That means from here you can generate 100. Fine. Again, this is false. That means zeros from 0 star 0, from 1 1, from 0 0, then 1 0 star means 100. You can go with any number. So it's a substring. Again, second is false. Third one. In third one, you never generate 100. But the point is, the question says that all such string which not contain 100. We have a string 0 which doesn't contain 100 as a substring. But this is not generated by my option C. That's why it is false. So D is the correct answer because every string which doesn't contain 100 as a substring is generated by option D. That's why D is true. So my dear students, always keep in mind instead of just thinking about in a one way, you have to think in the both the ways. Is my regular expression not generating the given thing? Plus, is my regular expression generating all such things? So you have to keep in mind these things. Next, which of the following regular expression is correct for the language set of all string ends with B? End with B. See, if I just draw the FA or DFA4 end with B, it's a very simple FA. We require end with B. Fine. Now it may be anything here. Yes or no? A and A. This is N with B. Now the first simple expression is A plus B ka whole star, but it has to be N with B. A simple straightforward expression. But these two expressions are absolutely true. How? Now see my dear students, just listen it carefully. Can I write? Suppose that we have a state S having two loop. One is A and one is B. Can I write it as A comma B? As simple as fine. Now, can you see here on state S we have two loop. One loop is like this. Please check it of A, and one loop is a big loop that is B star A. Yes or no? So it means I can write A plus B star A whole star, because this expression I can write as A plus B ka whole star now. Comma means plus, loop means star. So after covering the things, we are at state A. But anyhow, if you want to accept anything, you have to reach to the final state. And what is the path for final state? B, then B star. That is the longest path. B, B star. So can you check it? The option C, is it same? Yes, option C is same. That means we resolve the loop at state S. Now we can do the same thing for state A. Now at the state A, we have two loops. One is a loop of B and one is a loop of A star B. Yes or no? But if you are resolving the loop at state A, first of all, you need to reach to the state A. Having the longest path is A star B. That is A star and B. So you can see the option second, A star B, and then you are solving the loop here. That means all the three options are correct. Keep in mind. Even though by seeing you cannot identify what is the correct answer, but you have to know this technique. Next, consider following grammar. The language generated by the grammar is, yes. Again, this type of question you also face in your any of the upcoming examinations in from CSC and TOC. Yeah. What is the grammar? Grammar says that S determines A capital A small d. It means it always generate AD, AD, then again AD, then again AD. Yes or no? Again, by because here we have S, it is generating AD, 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 A to the power N, D to the power N. And when you call this production, it generate B and C, same number, B to the power M, C to the power M. But keep in mind, if you check the options, first two are saying that M or N greater than equal to 0. But no, because it is not terminated by epsilon. So first two options are wrong. Let's move on C and D. What D says? D says that A and C has to be equal. But in our case, A and D are equal and B and C are equal. But in this case, it is saying that A or C is equal. That means first A came, then C came, and then B and D are equal, which is wrong. That's why C is the right answer. What C says? AM, DM. Very good. And then B and C are equal. Yes or no? That is the right answer. C is the right answer. The number of derivation steps required to generate a string of length n if grammar is in Chomsky normal form. We know that we have two standard forms, one is Chomsky and one is Grayback. In Chomsky, you required 2n minus 1 steps to generate a string having length n. Fine. So what is the Chomsky form? It is either VV or T. Either in each production we have two variable or a single terminal. Next, consider the following statement. Very important problem. So the first one is expressive power of DPDA with final state is same as DPDA with empty state. Now, my dear students, keep in mind in DPDA, actually, you can recognize the language by two methods because DPDA has the power of stack. Either you can recognize the language by empty the stack or by reaching to the final states. So, my dear students, in the case of DPDA, keep in mind, final state method accept more language DPDA with final state accept more language than DPDA with empty stack. Final state method is more powerful. Okay, so but it is saying that same, which is false. Expressive power of DPD is same as PDA. No, that is absolutely false because a language WWR is only accepted by PDA but not DPDA. So both the statement are false. It is saying that which of the following statement are correct? None. Let P is a regular language. Okay. P is, given that P is regular. Q is CFL, but we don't know it's a only CFL, but not regular. We can't say like that. Okay. Which of the following operation results always regular language? So in this case, my dear students, we know that we have a closure property that regular is minus regular is always regular. So sigma star is what? Regular. P is what? Regular. So it always gives you regular. C is the right answer. Again, you have to know the closure and decidable property. Which of the following statement is or are correct? CSL is closed under intersection. Context sensitive language. Again, question related to the closure property. What about CSL? Context sensitive language. Is it closed under intersection? Yes. That's why it is true. REC, that is recursive Turing decidable, it's closed under complement. So if I talk about REC is almost close to each and every standard operations. That is true. DCFL is not closed under intersection. DCFL, yes, DCFL is closed under complement and intersection with the regular, but it is not closed under intersection. Fine. So it is not closed. The option says not closed. Yes, that is absolutely true. So all are true. The minimum number of states in DFA for language set of all string in which number of A is even and it's a and number of B is multiple of 3. It means we require all such string in which number of A's has to be even and number of B has to be multiple of 3. Fine. Whenever there is a composition of two languages, we have to perform the Cartesian product between the states of first language and the second language. And we know that in even number of cases, we have two states. And in multiple of 3, that's mode machine, requires n state, that is 3 states. So total number of states required is 6. So D is the right option. We already done a lot of problems where when what about the trap state, what about the extra states, we already discussed in our classes also. So students know how to solve these problems. And if you think that you want to join the dedicated batch, then you can just contact to the executive of YourPedia. So here the answer is 6. Now consider the following language. Which of the following options are correct? Okay, L1 is regular, L2 is CFL but not regular. So just talk about the regular and CFL. What is L1 language? By just seeing W and WR, we may think that it's a CFL but not regular. But you have to check these two conditions also. Here, both W and X belong to A comma B ka whole star. So by just putting W as epsilon, WR as epsilon, we can generate anything. And we know that it's just a regular. Second, X, W, Y, WR. Here again, X, Y, and W. All the three things are belong to A comma B ka whole star. In the similar way, we can generate it by writing X as A plus B ka whole star. You can say W as epsilon, I as epsilon. So W is epsilon, then epsilon reverse is also epsilon, which is again a regular. So if you are able to reduce your language with any regular expression, you can say that language is regular. So in my case, first and second both are regular. So C is the right option. If L complement denotes the LC denote the complement of language, fine. If L is decidable, that is REC. Both L and L complement are Turing recognizable, that is RE. This is absolutely true and standard theorem that if my R is if L is REC, Then L and L complement has to be RA. This is standard theorem. True. Fine. Next, if L and L complement are Turing recognizable, it says that it's a reverse process of the first part. If L and L complement are RE, then L has to be REC. Yes, that's absolutely true. So both the statements are true. Now, again, match the following. We need to match these things. So the first one, it's a CSL because there is no comparison, but the strings are not in AP or the power not in AP. That's why it is CSL. The second one, it's a regular, simple regular. There is no comparison. It's a to the 3n plus 5. Fine. If you put n as 0, then 5, then it's multiple of 3 again. Then third one is a to the power n, d to the power n. These two has to be equal and these two has to be equal. Fine. So one comparison at a time. That's why it is CFL, or even better, I can say it's DCFL. And next is WXWR, where X and W both belong to 0, 1 ka whole star. That's why again we can make it as a regular. So according to the option, we can match it. Which of the following CFG generate the language L, where my language is a to the power m, b to the power n, where m has to be greater than equal to n. That means number of a has to be greater than equal to number of b. And a first came, then b came. So from here, first is epsilon. You can generate in which what is the number of a and b equal 0. Then it generates any number of a. Then again, the problem is it can generate any number of b also. Fine. So this is wrong. In C, here you are generating the same number of a, but if you terminate a by epsilon, it is again false because it is equal in nature. That's fine. But the point is S determine A, B. Fine. And next, if you go with the A generates AB, then B generates BB, B generates BB, and again B generates BB. It may be the case. So here number of B has to be more. There is a chance. That's why the correct answer is B, and you can check it. B gives you the right options. Next, what is the language accepted by the following NFA? So it's a straightforward example questions. Language. So whenever you are writing the expression, always keep in mind, take the longest expression, and the longest expression is A star B, B star A star. But you also have one more A, that is plus A. Now see, first example. First example says that if you just take epsilon here and A, this is accepted. Then what about n triple B? From here you can also generate triple B A. Are you, or you can also, yes, that is also accepted. But can you generate B A B A B A A? So B A. What about next? No. In the second option, A star B star A star. That means epsilon you are going to be accepted, but in my case it's not. That is false. It says that only B is also accepted. This is false. So correct answer is C, because C gives you the correct option. Next, the last one. Identify the regular expression which denotes all string of A's and B's, where each string contains at least 2B. Very good. It means you have to find out a regular expression which generate all such string in which at least 2B are there. In first case, At least 2B is there, but it cannot generate a string which are end with A. Suppose that BBA. That's why it is wrong. In second option, again, this is the problem. So you cannot generate a string which is BBAA. Fine, that is the problem. Now, option C is the correct one because it says that anything at the starting, anything at the end, and in between, at least 2B has to be there. That's why C is the right answer. So, my dear students, in TOC, always keep in mind the closure property chart, decidability, regular language, and the context-free grammar. These four things are very important. You have to know. Fine. And again, YourPedia already running a dedicated base for ISRO. If you want to join, then please contact to YourPedia team. New subject is now going to be started within 2 or 3 days. So please join if you think that you want to crack the ISRO. Thank you. Thank you so much.